Good morning, students. This is Physics, chapter number 3, lecture 3. And in this lecture, we'll be studying about Kirchoff's law. So there are two Kirchoff's laws. So first of all, we'll be discussing first Kirchoff law. So first Kirchoff law is called Kirchoff's junction rule or current rule. Okay, so first of all, what do you mean by junction? Junction means a point where two or more things meet. Or for example, in this diagram, this point will act as a junction because here many wires are meeting. Okay, so this is a junction point. So first law is Kirchoff's junction rule or current rule, and it states that the total algebraic sum of all the currents meeting at a junction in a closed circuit is 0. I'm repeating it once again. It states that the total algebraic sum of all the currents meeting at a junction in a closed circuit is 0. Now, for example, look at this circuit. There are 5 currents I1, I2, I3, I4 and I5. Now, if I apply this rule, it says now all these currents are meeting at this junction or this point. So, sum of all these currents should be 0. So, now if I apply this first rule, so applying it I1 plus I2 plus I3 plus I4 plus. Now look here carefully. I5 is in opposite direction. So if I opposite its direction, it will become like this. So that means I5 will be taken as minus I5 because I am considering that direction to be positive, which is coming inside, and I5 is going outside. So minus I5 is equals to 0, or I can say from this equation I1 plus I2 plus I3 plus I4 is equals to I5. So that means total current entering the circuit is equals to the current leaving. So current entering is equals to current leaving, and this means that the law of conservation of charge is followed, which states that total current entering the circuit will be equal to total current leaving. That means there is no loss. Okay, so this is the first Kirchoff rule. Now second Kirchoff's rule. So second rule is called Kirchoff's voltage rule or loop rule. Okay, so it states that algebraic sum of all the changes in potential around any closed loop in a circuit is 0. For example, if I suppose V1 is the change in potential in any circuit. So and let's say there are many changes in potential. The total change in potential, that is V1 plus V2 plus V3 and so on, all the changes will be equal to 0 only. Okay, so now I'll tell you an example how you will apply these two rules. So basically, before applying these two rules, there are some rules. Okay, so now look here. Suppose in any circuit a battery is given to be of 5 volt, and if you are traveling and in this direction, okay, that means from left to right, then which terminal will come first? Positive terminal will come first. So write that voltage as plus 5 volts. Okay, now suppose same battery is there of 5 volt, but now you are going in this direction. So now first negative terminal will come first, so write it as minus 5 volt. In the circuit, we'll be using this rule only. If positive terminal comes first, write down plus 5 volt. If negative terminal comes first, write down negative 5 volt. Okay, so second is this. Okay, so now let us this rule was for a battery. Now there will be resistance in a circuit as well. So let us suppose there is a resistance R and current I is flowing in this direction. Now if you are going in the same direction of current, in this I am going same direction of current, so I will take the voltage as IR. Now same diagram is here, resistance R, I is flowing in this direction, but if you are going in opposite direction, then take the voltage as minus R. So if you are traveling in same direction of current, we'll be taking voltage to be positive. If you are traveling in opposite direction of current, we'll be taking that negative, minus IR. So now by using these two laws, I'll tell you how to make the equations to solve them. Okay, so look at this diagram. There are two batteries in this. There are 3 batteries in this, and resistances are connected like this. Now, what do you understand by loop? Loop means any closed part of a circuit. For example, this circuit has this loop and this loop. It has this also. So basically, it has 3 loops. Okay. So now, how to apply the Kirchoff law? So basically, there are 3 batteries. take take that many current, that much batteries are there. For example, here are 3 batteries, so we'll be taking 3 current. So let us suppose from this battery I1 current is flowing, from this battery I2 current is flowing, and from this battery I3 current is flowing. Okay, so now we have current in all the 3 branches of this circuit, this branch, and this branch, that is AB, DB and CD. Okay, so now we'll start applying Kirchoff's law. Okay, so now look here carefully. This is a junction point because देखो I1 is coming here, I2 is coming here, and if I reverse the I3, it is also coming here. So that means all these 3 are meeting at this junction point. So from according to Kirchoff's first law, the sum of all these currents should be 0. So from Kirchoff's first law, we can write down I1 plus I2 minus I3 will be equal to 0. This is from Kirchoff's first law. Now to apply second law, I have to take a closed loop. Let us suppose I am taking this loop. That is loop ABDA. ABDA. Okay. So now first of all, what we have to do, we have to choose any direction in which we'll be moving. Here I have chosen anti-clockwise direction. This arrow shows the direction that I have chosen. Okay, so I am going anti-clockwise. So first of all, let us start from here. Okay. So when I'll go from here, this is a resistance, and abhi I told you, if you are going in the same direction of current, you will take voltage to be positive. I am going in this direction, current is also flowing in this direction, so I will be taking 5I1. 5I1. Now proceeding, negative terminal is coming first, so we will be taking -5. -5. Again, we'll go like this again. Now positive terminal is coming first, so +6. Now look here carefully. I am going in this direction and current is flowing from B to D. I am going from D to B and current is flowing from B to D. That means I am going in opposite direction of current. So I'll be taking it negative. That is -2I2. -2I2 is equals to 0. Okay. So now considering this loop DCBD. Loop DCBD. Now try to write it yourself and then match it here. Okay. So now again I am choosing anti-clockwise direction. Going from here, negative terminal will come first, so -2. I am traveling in same direction of current, so 2I3 plus 2I3. Now again I am traveling in same direction of current, plus 2I2 plus 2I2. Negative terminal is coming first, -6 is equals to 0. So this is how I have written 3 equations and I have 3 variables I1, I2, I3. So solving them, we can easily tell what is the value of current flowing from all the 3 branches of this circuit. Okay, so to understand it exactly, we'll take one more example. Okay, so let us take one more example. So this is a little bit complicated, but it is easy if you'll make the equations. Okay, so now this loop or this circuit has 2 batteries, +10 volt and +5 volts. Okay, and the resistances are connected in such a way. So now if I want to calculate current in all the branches, now what I have to do, again I'll choose the currents first of all. So I have 2 batteries here. So abhi maine aapko bataya, I'll be choosing 2 currents. So let us say I1 is flowing from this battery and I3 is flowing from this battery. Okay, now look carefully. If I1 is flowing here, it will get divided into 2 parts at this A point. So let us suppose if I1 is going here, I2 is going there, and therefore from this branch what will be left? I1 minus I2. So I1 is here, I2 will be here, and I1 minus I2 will come here. Okay, so now come at this point. I2 is coming here, I3 is coming from here. So at this branch, what will come? I2 plus I3. Okay, so now come forward. I2 plus I3 is coming from here and I1 is going here. So that means यहाँ पे कितना होना चाहिए? Or you can say I2 plus I3 is coming in this direction and I1 is going in this direction. That means minus I1 is going in this direction. So यहाँ पे कितना आएगा total? It will be I2 plus I3 minus I1. Again I am repeating it. I2 plus I3 is coming in this direction and minus I1 is coming in this direction. So from here to here, I2 plus I3 minus I1 will come. Okay, so now we'll start making the equations. Okay, so now let us first of all choose the loop ABCA. In loop ABCA, okay, I'm starting from this point. I am traveling in same direction, and one more thing, I am choosing clockwise direction. You can choose any direction, either clockwise or anti-clockwise. The result will come to be same only. Okay, I am choosing here clockwise direction. Okay, this direction. Okay, so I am going in same direction of current. So 4I2, 4I2. Okay, again same direction of current. So plus 2I2 into I2 plus I3. Okay, so again like this, again in same direction of current, that means 1I1 plus I1, and negative terminal is coming first, so minus 10 is equals to 0. Okay, so now second loop will be loop BCDF. This loop BCDF, this loop. Okay, so again in this I am going in anti-clockwise direction. Now start from B, you are coming in same direction of current, that means 2 into I2 plus I3. Here again same direction of current, plus 2 into I2 plus I3 minus I1, and then negative terminal is coming first, so minus 5 is equals to 0. Okay, so third equation in this loop ACDA. Okay, so now in ACDA we are starting from the point A again, and we are going in clockwise direction. So it will be plus 10. Then you are going in opposite direction of current, so it will be minus I1. Then same direction of current, so plus 2 I2 plus I3 minus I1, and then again in opposite direction of current, that means minus 4 I1 plus I2 is equals to 0. So these are the three equations which we have made. Now you can solve them and you can easily calculate the value of I1, I2 and I3. Okay, so the next topic is Wheatstone bridge. Okay, so Wheatstone bridge principle states that if there are four resistances P, Q, R and S, and if they are connected in this form, in the form of a bridge, okay, and a battery is connected here, then if this galvanometer which is connected here shows no deflection, then this bridge is said to be balanced. Again I am repeating it. If there are four resistances P, Q, R and S which are connected in a form of a bridge and a galvanometer is connected in between them, when a battery is connected and current flows through it, then if this galvanometer shows no deflection, that means if Ig, the current flowing through this galvanometer, is 0, then this bridge is said to be balanced. तो कब होगा ये balanced? When Ig is 0, that means this galvanometer is showing no deflection. And when Ig will be 0, one condition will be followed in this. That condition will be P upon Q is equals to R upon S. So now you can say if this bridge is balanced, there will be two things. First thing, current through this galvanometer will be 0, therefore it will not show any deflection. And second thing, P upon Q will be equal to R upon S. Okay, so these two. Now we'll be proving this. Okay, so how we'll prove this? We'll prove this by using Kirchoff's laws only. So as you can clearly see here, we can use Kirchoff law in these two loops. So we'll be using these two loops. Okay, so let us suppose I1 current is going from this battery. I is going from this battery. I1 will go here, and then I minus I1 will go here. Okay, so again if I1 is going from here, and I am supposing, let's say Ig is flowing in this direction from galvanometer. Okay, so now I am supposing that this bridge is balanced already. तो अगर ये balanced है, that means Ig is 0. तो Ig is 0. Now I'll be proving अगर हम Ig is 0 लेके चल रहे हैं तो we should get this condition. Okay, so I am supposing Ig to be 0 only. Okay, so now we'll use loop A, B, D, A. In this loop apply Kirchoff law. What it will be, we are going in plus Pi1, Ig is 0, so this will be 0 only, minus R, I minus I1 equal to 0. From this we can write down Pi1 is equal to R, I minus I1 equal to 0. Next we'll use this loop, BCDB. In this loop, start from here, QI1. अच्छा, one more thing, if I1 is coming from here and Ig is 0, तो यहाँ पर भी कितना करंट आएगा? It will be I1 only, I1 to I1. तो here also it will be I1 only. So QI1 and plus QI1, and for this branch I minus I1 is coming here. इस ब्रांच में तो कोई करंट है ही नहीं, तो दैट मीन्स I minus I1 will go here also. So that means from here, if and I am coming in clockwise direction, तो plus QI1 minus S I minus I1 will be equal to 0, because in this the current is going in this direction and in this the current is going in this direction. Okay, So plus qi1 minus of si minus i1 equal to 0. And from this I can write down qi1 will be equal to si minus i1. Now by using equation 1 and 2 and dividing them, when you will divide them, you will get pi1 upon qi1 is equals to r into I minus i1 upon s into I minus i1. Now from this you can clearly see these will cut down, so you will get p upon q is equals to r upon s. That means when ig is 0, this condition will be satisfied and the Wheatstone bridge is said to be balanced. Okay, so after studying these topics, you can do these questions from your NCERT book, question number 9, 11, 15 and 18. Thank you.